In today's video, we are going to be looking at this question. It says a variable p varies inversely as the square of q if p equals to 5 and when q equals to 6, find q when p equals to 1.8. We all know that this is a WAEC past question on inverse variation. So one of the things you do first is that you first write it as an inverse equation, which is going to be p inversely varies to 1 over q squared. Then you write p equals to k over q squared. You have to multiply 1 over q squared by your constant of proportionality and see k is constant. Now, from there, we are given the value of p. Okay, first of all, let's make k the subject of the formula. Then k is now pq squared. So k will now be, what is the value of p in the question? We have 5. 5 times 6 squared. That will be 5 times 36. That means the value of k is 180. Now, we are going to put that value in the formal equation we get, where I write k is constant, so that we can get the relationship between p and q. So the new equation is now going to be 180 over q squared. This is the relationship between p and q. But we have to find q when p equals to 1.8. So this is what we are going to be doing now. When p equals to 1.8, that means 1.8 equals to, you substitute the value of p, q squared. So from here, you cross multiply. When we cross multiply, we have 1.8 q squared equals to 180. So q squared is going to be 180 over 1.8. When you divide 180 by 1.8, that will give you 100. That will give us square root of 180. Square root of 180 over 1.8. That's why you square both sides, so that we can eradicate the square on top of q. And from there, we are going to be having q equals to square root of 180 times 10 over 80. Now, if you notice, this is division of fraction. There, what we do is that it's supposed to be 180 divided by 18 over 10. But when you do reciprocal, so you get 10 over 18. And when you do that, you're going to be having the square root of 100, which will give us q equals to 10. If you check the option, that's q equals to 10. Also, don't forget to follow us on all our social media channels.